Hey, just in time today. What do you know? Perfectly 9 p.m. No, 9 a.m. Perfectly. Cool. I was just finished up setting up, but I think we are at the ready. Just making sure everything's fine and it looks like it. My mic it's a little hot. Let me get it a little bit less hot. I don't know. Maybe I touched some dial. I don't know. Maybe I did. It's looking better now. Still a little bit hot. Let's Yep. Better. Cool. So yeah, so today it's going to be chapter 11, which is called Controlling Access to Files. We will start soon. Just making sure that everything's fine. Let me hear myself. Hello, testing 1, 2, 3. Yep, everything's fine, which is nice. I mean, I have been I have been testing out this thoroughly, so I have no issues, and I think I don't. Chat is up. You can ask anything away. These live sessions are live on YouTube, on Ozzoy Bits YouTube channel, on the Ozzoy Bits Twitch channel. But on the Twitch, I am not saving up the VODs. You need to go to YouTube to get access to that. And on YouTube, the chat, it's members only. All right. So become a member. Any tier of member can actually ask questions and interact with me on YouTube. If you want to do it for free, you can go to Twitch. And yeah, VODs are recorded on YouTube. VODs are not saved on Twitch. Okay. And if you are a channel member, you will have access to a fully edited down version of this live stream. So without this jibber jabber, you'll go right to the point without any jibber jabber and gibberish. Let me just take out my coat. My jacket. The weather around here cannot make its mind. It's either cold as fuck or hot as shit. So you never know what to put on. So cool. Let's carry on. Everything looks fine. Everybody's joining in. Hello, everybody. We're going to start in a couple of minutes. Just letting people join in. Make sure that they are comfortable. They have their drinks and have their snacks at the ready. And we'll start soon. In a couple of minutes, tops. But maybe we should start now. Why not? Yeah, I had the intro running, so people had time to join in. So yeah, where to go? Let's go, for example, let's go here. I mean, look, it's fine. So I'm going to intro this again and start the recording. Here we go. Hello and welcome to chapter 11 of our Ozzoy Bits live classroom on the RH124. And chapter 11 is going to be all about controlling access to files. Okay, so we're going to do a few things. We're going to check file permissions and we're going to interpret them and see what they mean, and work our way from there on. Okay, and we'll work for our way from there on. All right, sounds nice. Nice, cool. So yeah, if you are a channel member, any tier member, you'll see the recording without the intros or jibber jabbers. And let's carry on. So let's go chapter 11, controlling access to files. And basically, we're going to something that seems to be simple, which it is, but has a lot to be said. So let's do an ls minus l. I was going to say something else. Oh yeah, if you're watching this in live on the vertical format, you can stay in the vertical. It's fine. But I'm also streaming in the horizontal, so you can see better what I'm doing. But if you're watching on your phone in the vertical format, stick around and you'll have some fun too. So ls minus la, we know this already. I mean, this is chapter 11 already. So this is a long list. Okay, so it means I can see all the details. And this is the A, which is all files, which means that I can see everything. Normal, quote unquote, normal files, hidden files, the works. And let's get something out of this, something really simple, a simple file. For example, this guy over here. Okay, let's get this guy over here and let's try to interpret all of this information that we see here. Okay, so all of this information we see here. Okay. Okay, let's pick this one, this file there, this guy there. Okay, this guy here looks to be fine. This guy. Okay, this is something we need to know. I'm still looking at this zoom in, zoom out thingy. So this seems to zoom in where the cursor is, which is fine. It's really awesome, this feature, isn't it? Oh my god! I know this is a cinnamon feature. This is so cool. So if you're using Linux, go to your accessibility options and enable the zoom in. It's so nice. So let's put this right in the middle and zoom in. Ooh-wee. This is so cool for training. Alrighty, very nice. Cool. So let's zoom out again. So let's interpret this. This is the thing we need, but I will just keep all of this here. Okay. This is something I want to keep. And this is the information we need. So this is also important. Yeah, it is, but this is kind of what we need to know right now. Okay, and this is what you need to interpret. Okay, so this piece of information right here. All right. What is it saying? Give me a second. Let me just check what he's saying. So yeah, let's go here. And did I press the record button by accident? Maybe I did. It's okay. Cool. So let's interpret what's here, what information is here. Okay. So it's first interpret these letters here. So we have at first we have a dash, RW something, R something something, R something something. Okay. This is quite simple. Well, it may be simple. It's not the right way to say it. Let me check the chat. Yeah, maybe simple. It's not the right way to say it, but it's doable. Let's say it like that. So the first thing here, which is a dash. Okay, let's maybe we go to our tablets here, so we can take some notes. Maybe that's the way to go. So for example, what we see there is, let's put handwriting. So in that example, we saw a dash, RW, RW dash, R dash dash, R dash dash, a dot. Then we saw a user and a group. Okay, that's what we saw. So the first thingamajig, the first symbol or the first letter, whatever the case, in our case it was a dash, but it can show different things. For example, if we see a dash, means this is a regular file, just a filer. It's a file, for example, a text file. Okay. And you can also see a D, which means directory. This is kind of the two common one, directory. So these are the two most common ones. If you see a dash, it's a file. If you see a D, it means directory. Okay. And that's basically it. But there are some other examples. These are the ones I'm going to see them this week, but well, not this week, but throughout these sessions, which is a dash and the D. But for example, we can also see a lowercase L, which means link, soft, because a hard link will show as a dash. And you can also see a C, which means character device. Oh my God, my handwriting. Character. You can also see a B, which means block. In simple terms, in very simple terms, file means file, directory means directory, link is soft link. That's something we already know. Character devices are special devices. Well, I have not blown your mind, right? What is a character device? For example, the dev null is a character device. For example, the random and the urandom are also character devices. And I'm trying to clean something that is annoying me on my tablet. And please go away. Please go away. It's really annoying. Cool, it's gone. And I'll show you. I will go to the console and show you in a second. And also have B for block. Block devices are storage devices. Okay, USB devices, NVMEs, and so on and so forth. Okay, those are block devices. For example, let me show you in the console here in a second. So where's my mouse? Just where is it? Oh, here it is. Let's go here. Here we can see that the dash, it's a regular file. The D, it's directory. I believe I have some links here somewhere. Oh, there it is. So if I do an ls minus la, so regular file, this is a link, a soft link, like I mentioned. I can show you dev null. So dev null, as you can see, it's a C, which means character device, which is a special device. I will not detail too much what this means. Not right now. Maybe in the next training, the RH134 will dwell through that, but not at this point. Then for block devices, for the block devices, it's easier if I do something like this: lsblk, and do nlsl minus la, and dev, for example, nvme 0 and 1 p1. See, it's a block device. Why does it show as the name as block device? Because typically and historically, it's still true, storage devices are divided in blocks. Okay, so if you are an old school person, you know what I mean. A block device is a device that's, well, storage devices, historically speaking, were divided in blocks. That's why it's called block device. So it's called a block device because of that. I don't like when the light pops here, that's why I pulled it back. So it's called a block device, which means because storage devices were, historically speaking, and still up to today, they were divided in blocks, in squares. So it's blocks, so it's called block device because they are devices that store blocks. That's pretty much that. And that's nothing more to add. So B, block device, which means storage. C, character device. Special devices, dev /null, dev random, dev random, for example. We'll see many examples throughout this training and the next one. And we have block devices, which are storage devices. We will discuss storage later on in more detail. So like, subscribe, and hype to get notified. And that's it. So basically, throughout today's session, we're going to discuss the dashes and the Ds. Yeah. Saying this like this, it sounds really weird, but yeah, we're going to discuss the Ds and the dashes, which are files and directories. Maybe we'll dabble a little bit on the Ls, but we have discussed the Ls previously, so I will not go much through that again because we went through that previously. Okay, cool. So let's swap here, go to the chat, and here we go. So yeah, we're going to discuss especially the dashes, which are files, and the D, that means directories. So another thing you need to know or understand, maybe understand it's a correct term, is that in Linux, probably you have heard this before, in Linux, and I know Linux is a kernel, it's not the operating system. I am well aware of that, okay? I am well aware of that, don't worry. In Linux, there is a saying that says everything is a file, okay? Everything is a file. And that's true. Everything is a file. Even directories are files, okay? Even directories are files. So it's a special file at that, true, but even directories are considered files with special sources, with some special magic around them. Of course, there are, but they are, for all intents and purposes, a file. And you also have seen that even devices are. Let me show you again. Even devices are files. For example, I see here my storage device, and the storage device is popping as a file, as a block device. So yeah, everything is in Linux, everything is a file, that's for sure. So directories are files are files, storage devices are files, even for example, USB ports are files. So everything is a file or is represented as a file, okay? So everything is literally a file or is represented through a file. That's quite interesting if you ask me. All right, cool. So it means that everything we do should be in some way or form represented through a file. Okay, even directories are files. Okay, and we will come back to this in a second. So let's discuss the three possible permissions. But bear in mind, that these three permissions we're going to discuss here are not the only permissions that are in existence. Okay, there are others. We're going to discuss the kind of the standard permissions, but there are others that are called access control lists or ACLs. Okay, so we're going to discuss here the what we call the standard permissions, but there are other permissions called access control files, access control lists, sorry, that we'll discuss later on in the RH124. All right. So these are the standard permissions. Standard perms. Okay. And there are three, which is the R, the W, and the X. This is read. This is write. Oops. And this is execute. It's so execute. I digress. So they are pretty much self-explanatory for the most part, but I'll tell you anyways. Read means read a file. For example, when I get a file to see its contents, I am, for all intents and purposes, reading that file. Let's do this in a different way. So let's separate this from files and folder. Okay, something like this. So I'm going to give you an example of reading a file. For example, get the file and see its contents without changing the contents. Oh shit! Let me just redo that R because it really sucks. I'm sorry, I'm looking at my phone so much because I'm receiving customer contacts. So read. Jesus, my handwriting sucks. Always did. Is to get the file. Okay. So to get the file means to see its contents without changing the file. Well, checking the file contents without changing the file contents. Write means, for example, on VI, you do the write quit thingy, or the X, for example, or you do the output redirection. So you are, for all intents and purposes, changing the contents of the file. Okay. Execute. It's when the file is executable. For example, when it's a binary file, or when we kind of want a script to act like a script. So read the file, get file, write, change the contents, WQ or X, or output redirection. Execute, it's when the file is a binary, which by definition, for the most part, means it's executable. And the script when you convert a text file into a script. So pretty simple for the most part, right? Nothing really special here. Pretty much self-explanatory, right? For the most part. But when you reach the folders, that's slightly different. So I'm going to give you a few examples, and I'm going to leave the last one for you guys to think about it. So what does it mean to read a folder? Means to list its contents. Okay, to do an ls to a folder, that's what it means. So when I want to read a folder, basically I'm listing its contents. The W, which is write, it's when I create or change files within the folder. Okay, so this is listing the contents of the folder. This is create new files or change existing files on the folder. And what does it mean to execute a folder? This is kind of the brain twist thing, the brain twist part of this. What does it mean? Do you guys know what does it mean to execute a folder? So I'm going to give you guys a couple of seconds because there is a delay in the stream always. So what does it mean to execute a folder? So read the folder is to list a folder. Write it to create new files or folders within the folder or change existing ones. What does it mean to execute a folder? What does it mean to execute the folder? I will let you guys think about this, And I'm going to let you guys tell in the chat if you want to. Once again, Twitch chat is free. YouTube chat, it's members only, but any tier of membership will function. Any tier membership will function in YouTube. Twitch chat is free. So if you want to answer for free, twitch.tv/Ozzoy Bits. If you want to interact in YouTube, you need to be a member of any tier membership. What does it mean to execute the folder? To execute the folder means to cd into the folder, okay? So the change directory command only works if you have the cd permission to that folder, okay? So read the folder, it's to ls a folder. W, it's to create new files on that folder or change existing ones. Execute, it's to cd into that folder, which makes it quite funny. For example, if you have, you can work, tailor permissions to work like this, which you have the X, you can cd into the folder, but you are unable to list the contents of that folder. Or you have the write, you can write files to the folder, but you are unable to cd into it, and you are unable to ls the contents. See? So you can actually write files to the folder, but you are unable to list or cd into it to confirm that a file is there. It's uncommon, I get that, but it's technically possible to have such results. So you can actually list, or for example, you can list the contents, but you are unable to create or cd into that. So you can ls using the absolute path name, for example, ls etc something, but you cannot list the contents or create new files. I mean, the other way around. You can ls, but you cannot cd into that. So, for example, you do ls etc something something. You see the contents and you see, hey, I want to go there and do stuff. You cannot neither cd or write to it. So it's very interesting what you can do with these simple permissions, and it's quite interesting to know that sometimes, or for example, we have a drop folder. A drop folder means you can copy files to that folder. You can cp or move files to there, or touch files there, or create new files there, but you are unable to confirm that a file is there because you cannot ls. And if you cannot cd, you cannot go inside it in commas. You cannot go inside it. But if you don't have the ls, if you do not have the write, then you can cd into there, but you cannot ls. So as you can see, the folder permissions are very, very interesting, and also in a way very, very, very powerful. So powerful so that things like this can happen. So let's say you have a folder here. So this is my rendering of a folder symbol. And we have here file 1, you have file 2, and you have file 3. Oh, before I go into this, let me just continue with that where we started, because it's important. So yeah, so now you know what these mean, the 3 characters. But why do I have three groups of those letters? Because of the UGO, which means this is the user permissions, these are the group permissions, and these are the other ones. Who is the group? Who is the user? That's what's listed here. Okay, this is the user owner, this is the group owner. Okay. If you guys remember when you talked about how to create users and groups, I discussed this in that section, but you can go back to that video. It was about chapter 10. So basically the previous one. When you create the user, that user will automatically belong to his own group, which means if I create the user Bob will belong to his own group. This does not have to happen all the time, but by default it does. Why does Bob belong to Bob? Because when Bob creates a file, the file needs to belong to a user and needs to belong to a group. And by default, it will belong to his user and to his group. So when I create Bob, the group Bob will be created and Bob will belong to it. Why? Why is that mandatory? Because when Bob creates a file or folder, that file or folder needs to belong to a group. There is no way for a file to belong to no group at all. It needs to belong to a group. And by default, it will belong to his own group. Okay? So these are the permissions for the user. These are the permissions for the group. And these are the permissions of someone who does not belong to the user or the group. So Bob, in this case, imagine this says Bob here. Bob will have this group of permissions of the user and this group of permissions for the group. For example, if it's Alice that is not Bob or does not belong to the Bob group, Alice will inherit the others permissions. So let's say I am Alice, okay? And I'm trying to access a file with this set of permissions. Since I'm Alice, I am not user Bob, and I do not belong to the Bob group. So I will enforce the others permissions. As simple as that. Janice comes along. Janice comes and says, "Hey, Janice, you don't belong to you are not Bob, obviously. You do not belong to Bob group. So you are going to get entitled to the other one's permissions." Pretty simple. Now, you also have a dot here. And that dot that I put there, it was not an accident. Because if you go to here, you will actually see that. You will actually see that there is actually a dot here, okay? So that dot that I put there, it was not by accident. It really exists, okay? The dot means it's literally a full stop. It means that permissions are just, we are done. There's nothing more to see here. It's for all intents and purposes, a full stop, nothing to see here. There are a couple of special cases, especially when we start to deal with access control lists. But for now, just that's what you're going to go with. That's a full stop. It actually means permissions are done. There's nothing to see here. We're done. It's a full stop. Simple as that. Okay? So that's just to wrap up things. Not wrap up, but review really quickly. So this is the user group permissions. Not that. These are the user group. This is the user's permissions. This is the group's permission. This is the other's permissions. Okay? So this is Bob's permissions, Bob group permissions, everybody else. As simple as that. So one thing that can happen is, for example, in this case, the user has read write, the group has reads. So Bob is the user and Bob also belongs to that group. What are the effective permissions for Bob? Usually without exception, with some exceptions, but let's not discuss exceptions for now. It means that the most specific permissions apply. So what is more specific? A user permission or a group permission? A user permission. User is more specific than a group. Okay? So the effective permissions for Bob are read and write. Cool? If Alice comes along, let's use a different color. I don't have that many colors, but these will suffice. Alice comes along. Is Alice part of the user group? Nope. Is Alice part of the group? Nope. So these are Alice's effective permissions. She inherits the others group, which is just read. Alrighty then. Oh my God, if someone arrives, now the live stream, look at my screen, they go nuts because what the hell is he doing there? What is SpaghettiOs? Cool. Now, going back to the folders, to this example here. So let's say we have here a folder, all right? We have here a folder. And let's say that, for example, the user owner is Bob. The group owner is Bob, okay? And Bob as a user has read, write, execute. As a group has read, write, execute. Let's go to this example. So Bob is the owner of this folder. The Bob group is the owner of this folder and has full permissions. Now, when they go to this file, okay, the file reads something like Alice. Jesus, my handwriting still sucks after all these years. ls. This file reads from, so this is the user owner, this is the group owner. Okay. File 2 reads something like, I don't know, dads, something really short. And this one reads, I don't know, Rick. Doesn't really matter. So the owner of this file is Alice, owner of this file is Dad, owner of this file is Rick. So in other words, Bob does not have any effective permissions on the files. And this can happen very often. So Bob does not have any effective permissions on the files, but he does have permissions on the folder. Okay? So at first glance, if Bob tries to change the contents of this file, he will not be able to, right? Because Bob doesn't have any permissions on the file that belongs to Alice. But remember, Bob owns the directory. Bob owns the directory, which means he can what is called force a save. Jesus. Okay? So if Bob is the directory owner, he can force a save to files he doesn't have direct permissions to. So even though Bob does not show up in the owner, group owner, or any other permissions, for example, the other permissions mentions just reads or nothing, even if Bob doesn't have any permissions as the owner or through the other permissions, what did I do? I didn't even know I could do that. I'm learning something today. Strange. How did I do that? I don't know. So even though Bob does not have any permissions either by the user group, by the others group, or by the others or the group, whatever, Bob has no permissions on these three files, whatever format it's that. Because Bob owns the folder, he can force saves and force reads on the files. Of course, there is a consequence, which is if Bob forces a save on this file that belongs to Alice, Bob becomes the owner. That's intentional. So the file code goes from Alice to Bob. Why? Because if Bob is the owner of the folder, he can force his shit over the files. How did I do that? I don't know. How can I move that with the pen? I need to figure that out. So since Bob is the owner of the file, since Bob is the owner of the directory, he can force himself on files he doesn't have any specific or direct permissions to. There are some consequences. That is, he will just become the owner of the files as a consequence, but he can. So it means that if you are using VI, for example, you'll see at the bottom saying you cannot. It's a read-only file, but you can force yourself to be able to write to the file. You become the owner, but you can. Funny thing. So if you are discussing permissions and trying to understand what are the effective permissions of someone to a file, make sure to check the folder first, because the folder, if the user has rights on the folder, if the user has power to the folder, he can force himself the same power to the files. Ain't that nice? Now you know. Cool. Checking chat, everything's fine. Checking Twitch. Everything's fine. Cool. I just want to make sure that the live stream is getting through to everybody. Cool. I have no, OBS is telling me everything is okay, but you never know. Cool. Cool. Now let's go back to the console here. This sounds fine. Cool. So yeah, that's how we interpret that's how we interpret the permission. So let's translate that to the actual system. So here you can see all the things I'm mentioning. So read write, okay? This is the user. This one. This is the user. This is the group. These are the others. This is the kind of the full stop. You can just, there's nothing else to see here. And you have the user owner and you have the group owner. All right. Cool. Then you have the things we already know. Change, file change, and everything else. So everything's really nice and dandy. Oh my God, what am I doing? Oh, I was just using the wrong key combination. Okay. Cool. So this is the file size. This is the creation. I made this file in the 11th. That's interesting. So yeah, this is the file size here. Let's put this a little bit up. This is the file size, and these are the links. As simple as that. So that means that apparently these three files are hard links to one another. Do you remember how do we find out if they are hard links to one another or not? ls, li, lie, and then we just compare. Let's put this up a little bit, and then we compare the inode numbers. Inode number, it's the same throughout these three, which means these are three hard links. Ain't that nice? Cool. Now we know how to interpret permissions. So this is the user, group, others, user owner, group owner, links, file size, change date, and the file name. As simple as that. And you already know that this means soft link. This is an L for soft link. And that's pretty much that. I mean, if you remember, I would recommend you guys to remember this. Let me show you again. It is kind of the twist, what means to read a directory, what means to write to a directory, and what it means to execute a directory. If you can actually remember this and get that up to speed and remember the differences and all, and all of that, and remember that there are differences between files and folders, and remember that what it means to execute a directory, and also remember that if you give someone very strong permissions to to the folder, it kind of give him quite big amount of powers through the files. You are pretty much okay. So if you're watching this as a VOD, you can watch this again and again and again, and listen to me to explaining what this is time and time again. If you are a member, any tier member, you can watch this in the edited down version without the jibber jabber, and you can go right to the point. Cool. Yeah, and also if you are a channel member, any tier, you can chat with me on YouTube. If you want to chat with me for free, you can go to Twitch. But on Twitch, I'm not saving the VODs. I'm saving the VODs only in YouTube. Cool. So what's next? So let's do a couple of things more, and then we do a quick coffee break, which is managing file permissions from the command line. So yeah, so how to list the permissions? We have done that. It's quite simple. It's just by doing so like this. Okay. And we are done. Okay. And we are pretty much good to go. How do I, let's talk about how do I change the permissions. Why not? Let's start with I'm going to say the easy part, but it will depends on each person. But let's say I want to change the file owner. Okay, so this file, it belongs to the student user, right? So I want to change the user owner and the group owner. How do I do that? Well, change owner. It's the way we do it. That's change owner. That's all I have to say, because that's all there is to say. So if I go to the channel, change owner, change follow group, it's pretty much that. How do I do that? So I can do change owner. And I say, okay, I don't remember. I don't remember which users I have here. Let's see. Oh, I have Alice, Bob, and Rachel. How nice. Cool. So change owner, Bob, follow original. Oh yeah, I need to. Do I have sudo enabled? I don't remember. Do I? I do. Cool. There you go. So Bob, it's now. And the interesting fact is that I changed here. Okay, I changed here, but it changed for all three because they are hard links. Remember, so all these three files are the same file basically. So it's I change one, I change for all. Change the group. Change group. I mean, it's pretty boring, right? It's quite simple. So change owner, change the owner, change group, change the group. That's as simple as that. Okay. So owner, group. Pretty simple. However, you can use the change owner. You can use the same command for both. For example, let's say Alice student. Okay, you can use the change owner command to change both. In this case, I changed only the user. I mean, I changed both in this case, but you can change only one. For example, if I do like this, and Rachel, I only change the group. So basically, interpret this as the left side, it's the user, the right side, it's the group. And of course, if I do something like this only, it's just the owner. I can put the column there. It makes no difference. It's fine. So I can use the change owner to use the user and the group in one sitting. Okay. Or you can use the change owner and change group. That's also fine. You can use the change owner and change group. That's fine. But you can use the change owner to change both. Again, it's exactly the same thing. Exactly the same thing. By using one or one for both or one for each action. I mean, use the one you want, man. It's always the same thing. It doesn't really matter. You can save some time by doing this, but how much time do you save? A couple of seconds. Maybe that's relevant. I mean, take your pick. Cool. Now, that's done. Now how can I change the permissions? Okay. For that, let's go back to the tablet here. Okay, you have two methods to change the permissions. Again, they are both right. There is no one that is better than the other. They are both fine. You can use the what I like to call the alphanumeric. It's with the F or PH. Alphanumeric. It's with the F or PH. Let's use an F. Alphanumeric. Or the binary format. Let's talk about the alphanumeric. Is it alphanumeric? I don't. This doesn't matter. You will see what it means. So R means read, W means write, X is execute. That's easy. Now the binary format, which means that I'm going to give to each permission its binary value, and it's quite easy. So this one is worth 1. This one is worth 2. This one is worth 4. So it means that if I want to do something like this, it's 4 plus 0 plus 0. So this is 4. If I do read write nothing, it means 4 plus 2 plus 0, which means 6. If I want to do read, write, execute. It's 4 plus 2 plus 1, which 7. Wow. Is that easy? Yes, it's that easy. So if you have three, if you see, for example, 640, it's user, group, and others, which means it's read, write, read, nothing. Wow. Is that it? Yeah, it's that it. Simple, right? Again, there is no good nor bad. Everything is fine. You can use whatever method you prefer. It's just pick the one you want and you are good to go. Examples. Let's create a new file. So let's touch a file. And for example, let's say I want to change this to read. I can do chmod. And now with the alphanumeric methods, I can do, in this case, I can say remove the write from the user. So let's do user, remove write, and file. See, I just subtracted the write permission. I subtracted the write permission from the file to the user. And it's gone now. Ain't that nice? I can give back. Or I can say to the group and the user and the group, the user group and the others. If I give, I can take away. And so on and so forth. Yeah, pretty simple. I mean, it's fine. It's as simple as that. You can give and take away. So in Red Hat, when you specify nothing, just like this, he will just do to all three. So let's give it. So not all three, the first two. It will depends on each. Okay. Oh, in this case, he's just touching the user, not the rest. It really depends. So since I am very easily distracted, I usually do this method. Now I know. Because they change this between Red Hat versions. So this is 10. So in 10, by doing this, and you don't say if it's user, group, or the others, he will do to the user. But in the old days, he will do all three. So who gives a shit? Just specify the one you want. Binary files. It's at chmod. So if I check the one that it's right now. For example, so I want to give this read. So chmod 444 file. Yep. 644. Yep. That's why when you get the 777, you give all three. Because 777 is 4 plus 2 first one. Whee! Which one is better? There is no such answer to that. There is no better. There is no worse. There is just ways. In the end, everything ends up here. You say? Okay? So in the end, everything ends up here. In the end, everything ends up here. So use the chmod binary, use the chmod alphanumeric. Who cares? Everything ends up in the same location. So use the one you prefer, the one you remember. Who cares, man? Just do it. If it's a folder. Surprise, surprise. The exact same shit. chmod 644 folder. Exact same shit. But it's a folder, and as we know, in Linux, everything is a file. So basically, a folder is a file. So watch this over and over again. That's a good thing of these type of live sessions. The VOD will be recorded and saved for future reviews in YouTube. If you are a channel member on YouTube, any tier, you'll be able to see the edited down version, so you don't see the intros, the intro music, and also the coffee break. I need to take a pee. Let's go and take a break, have some coffee, and I'll see you in 5 to 10 minutes. I'll see you there. Okay, I had an espresso coffee. It was so nice, refreshing. All right, so we are halfway there. Well, more than halfway. So let me check my notes here. So yeah, so we did check the how to read the file permissions. We did that. We also did managing file permissions from command line. We did that. Yeah, we did for the most part. Okay. So now we're going to do managing default permissions and special permissions. All right. That's the thing we're going to do next. So let me get an image going. Yeah, let me get a print screen going here. So it's a shame that this tool I'm using for the note taking, which is, maybe you guys know, give me a hint here, which is Ocular. It's for KDE, but works fine in Cinnamon. I want to paste. I cannot paste images to put to a PDF. That's something I really would like to have implemented, but that's fine. We can just use the good faithful GIMP for that. Not ideal, but we will. 1 second here. So file, create from clipboard. There we go. We'll just use a good old GIMP here. It will just suffice just fine. So let's get something to, yeah, white will be fine. And yeah, so they're going to discuss, well, before we carry on, what we discussed, it's basically the bread and butter. All right, the 3 permissions: read, write, and execute. The user, group, and those permissions. And I mean, at the end of the session, the VOD will be there, and just watch it again. And if I remember, you will be able to see it also in a edited format. Like, subscribe, and hype, all that good stuff. It really helps. So yeah, we have 2 things to discuss here, because the first hour or so that we discussed permissions, it's pretty much that. There is nothing much more to add to that. It's basically that. Okay. There's nothing much more to add to that. It really there isn't, except for the ACLs, the access control lists. But that's for the RH124. So we have 3 special permissions to discuss, which is the SUID, SGID, and sticky, which means set user ID, set group ID, and sticky bit. Okay? Set user ID, set group ID, and sticky bit. Let me just check something here, because I want to make sure that the text is readable. Oh, it's perfectly readable. Holy shit. It's not blurry at all. Cool. That's nice. So yeah, what do they mean? Well, let's read, let's theorize a little bit, and then we can dive into the specifics. So set user ID. File executes as the user that owns the file, not as the user that ran the file. Take a deep breath. I will discuss this in more detail in a second. SGID, set group ID. File executes as the group that owns the file. If it's applied to a file, if it's applied on the directory, files that are created in the directory have a group owner to match the group owner of the directory. I will show you this in the console. Let's just read it through. Sticky bit on files does nothing, and on directories, users with right access to the directory cannot delete or rename files that they do not own. It sounds complicated. All three, they sound complicated, but actually they are not. They're actually not. They're actually not that complicated. But I will explain one by one. All right? So let me pull this to the side. Well, before I do, let's just discuss the first one again. So set user ID. File executes as the user that owns the file, not as the user that ran the file. Let's read this again. File executes as the user that owns the file, not as the user that ran the file. Let's see this in quite an obvious example. Okay. I'm going to give you an example, which is the example I use almost every single time because it makes total sense to use this example here. And before I carry on, let me make you guys a couple of questions. The first question is, what is the file that contains the user's passwords? In other words, what is the file where the system writes the user's passwords? In other words, when I use, for example, the pastlbd command, when I use the pastlbd command, where is the file? Where is the user's password stored? So when a user defines his password, it needs to be written down to a file. What file is that? And at this point in time, the thing that I said beforehand in the start of this chapter, it was or still is, in Linux everything is a file, right? So now we are getting more and more confirmation of that. In Linux everything is a file, right? And we are getting that more and more and more. So, what file contains the user's passwords? You guys know the answer. I'm pretty sure you do. The file is the etc shadow. Okay? And me, as a regular user, I am unable to see the contents. Am I able to change the contents? Nope, obviously not. Let's check the file contents permissions. So this is a very special file because it has no permissions. And the only person, the only regular user that it's able to change the file contents of this file is the root user. All right. So the root user is the only regular user that is able to change the contents of this file, even though the file has no permissions, at all, the root user is the only user that can change the file contents. All right? And why is that? Because there is a very intentional kernel, let's call it backdoor, even though it's not, that allows this to happen. So, only root can change the contents. But I will not change the password because it's just, I am lazy and it takes too much effort. But if I wanted to, I could use the root user. Me as a regular user, like the student, for example, I could change my own password. I would perfectly do that. So Only root can change the contents of the shadow file. The shadow file contains the user's passwords, but a regular user can change his password. So that's a conundrum, right? So only root can change the contents of the shadow file, but a user can change his own password. Why? Because he does that through the passwd command. Okay? And if I check the contents of the passwd command, you will see that it is an executable, but it has a special letter here, right? It has an S. And if I check the S here, what does it say? File executes as the user that owns the file, not as the user that ran the file. So let's check this again. File executes as the user that owns the file, not as the user that ran the file. One more time. File executes as the user that owns the file, not as the user that ran the file. Okay? So in this case, file executes as the user that owns the file, not as the user that ran the executable. So if I run this as student, this file will run as root and not as student. Why? Because it does have this permission here. It does have the S, which means if it has the S, file executes as the user that owns the file, not as the user that ran the file. Which means that when I run as student, the passwd executable, it will run as root and not as student. Why? Because the executable, and this applies to executables only, the executable will be ran as root because root has the permission, has that S there. If I remove it, it's easy enough to do. So sudo chmod user -s. Oops. And now you will see that now the S is gone and sorry. And also the executable lost that permission, which means that now when the user student runs passwd, it's not going to be run as root anymore because it does not have the S there. So if you want to make sure, one easy way to make sure that only root can change passwords, it's by removing the S. By default, most Linuxes, and I did not use all Linuxes in the world, as you might imagine. By default, most Linuxes have the S there. So everybody can change the password, but you can also revoke it at any time. So now without the S, only root can change passwords. Regular users are inhibited. I like that word. Regular users are inhibited to change their password like they usually could. Why? Because with that S, the S means this. So that's what it says. With the S, file executes as the user that owns the file, not as the user that ran the file. And this applies to binaries only. So let's give it back. Oh, one other thing. Well, let's give it back first, and I'll show you what I mean. As you can see here, it has an S, a lowercase s. It has a lowercase s here. So, and in the space where the S is, also the X can be there. So the S and the X are kind of competing for the same space, for the same character space. We have one character space, but I can read here an X and I can read here an S. So how do I know? Since the S, where's the camera? Since the S is in the front, how can I know if the X is behind it? How can I know they have both permissions applied, the S and the X? How do I know they have both of them are there? How do I know that? Because of the uppercase, lowercase. So lowercase means both are there. So let's say if I go here and I remove the executable, now the S, it's in uppercase. Uppercase meaning I am the only one here. So it's uppercase because it means I am the only one here. Okay? So let's put it back. So uppercase means I am the only one here. Lowercase here means I'm sharing this space with the executable. How cool is that? So that's what it means when an executable, and this applies to executables only, file executes as the user that owns the file, not as the user that ran the file. Right? And the possibility, there are not many executables by default with this permission applied, but the possibility it's one of them. All right. If applied on directories, it does nothing. Okay. If applied on directories, it does nothing. Cool. Now let's go to the G plus S. Well, this first part is easy. So I can show you here. So I could use the G plus X. Whoops, let's clean this up. Now it appears, S appears on the group, which means executes as a group. It's the same thing as the previous one, but applies the group and not the user. I mean, pretty simple. But the G plus S is specially used in directories, not in executables. So let's say, for example, mkdir collaboration. So the owner of the folder is student, which makes sense because it was student that created it. So since it was student who created it, is the owner. So far, so good. Now let's say I create a file. Again, this all makes sense. But let's say, let me see what groups do I have. I forget. Referees, for example. So let's say I want the referees to be owner of all files created from here on. For example, so let's say all future files, the referees group need to be the group that owns new files. What do? I just say so right now, the referees group, it's the group owner of this new folder. This does not change much, which means if I touch a new file, it still stays the same. But if I do chmod, G plus S to the current folder, you'll see now that it did not change. Oh. Okay, now I have an S here, which means set group ID is enabled, which means that the file I'll create now, student 3 should read student referees. So when the folder has the permission, the G plus S applied, the set group ID, in the folder, new files belong to the group owner. So that's a cool way to make sure that new files created. So of course, this only applies to the files created after I applied the permission. So if you see an S here, if you see when, not if S, when you see an S here, new files created in that folder, you will see that it will contain, so if the group belongs to referees or whatever other case, and the group ID it's applied, you will see now that the referees actually pop as the group of new files. So you apply the permission, all the files created from there on will belong to the group referees that matches the folder, which is nice. So if I check here, files that are created in the directory have a group owner to match the group owner of the directory. Files that are created in the directory have a group owner to match the group owner of the directory, which actually applies. Referees is the group owner. Referees has the set group ID. Referees will have the... After you apply this, new files will belong to the referees group. Ain't that nice? Ah, so nice. Cool. Now let's check the last one, which is the sticky bit. No effect on files. You can apply to a file, but it will do nothing. Users with right access to the directory cannot delete or rename files that they do not own. It's simpler than it seems. Let's go back to my previous example here. Remember this? Bob was the owner. I can move the, I was not aware of that. I can move the circle. Wow. Really? I was not aware of that. Can I? This moving the whole thing, but I can move. Oh, well. I'm learning new things about this tool every day. Ooh. How can I select then? I can move the arrow, can I? So what is the logic? I drag. Oh, I see the arrow, and the arrow points to something like I can drag. Oh. I was not aware of that. Anywho, if you remember, oh, it's that tool there. It's that tool. Is it a tool? This is the eraser. So how was I able to right click? Interesting. Well, if you remember this, Bob was the full owner of the folder, which means since he owns the folder, and by owning, I mean he has full permission. Since Bob had full permissions to the folder, he could do whatever he would like to that folder. You remember this, right? Right. So, if I go back here, I need to go to the bathroom to do a quick pee-pees, but I'm going to leave you a question. What default system folder, so something that exists on every Linux system, what default system folder that exists in almost, so I'm saying almost, so I don't say every, because I'm not sure, and I did not use every Linux in existence. In almost every Linux allows everyone to write there. To write. So the question is, what default system folder that exists in almost every Linux allows everyone to write? So there are a couple of system folders. By system folder, I mean default folders that every Linux has, that allows everyone to write there. Everybody has write permissions to those couple of folders. Do you know what folder that is? If you do, put out in the chat. I'll be back after my peepees. Sorry for the interruption, but it was a urgent peepees. Cool. So let's see if someone chimed in. Nope. Okay. So what default system folder that exists in almost every Linux allows everyone to write there? It's the temp and var temp. So let's check. So if I check the temp folder, oh, I forgot to put this. Blah, 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 blah. So as you can see, everybody can write to the folder. Everybody can write, which means, I mean, write and everything else, of course. So let's go there. And for example, since everybody has full permissions to the folder, right? So it means that, for example, let's say I want to touch a file here, student. I can write to the folder, really. So it means that I can delete this. Nope. So what does this mean? It means that I can write to the folder. I have full permission to the folder, but I cannot delete that. But I can delete this. So I have full permissions, but I cannot delete everything in this folder. I can write whatever I want here, but I cannot delete everything. Correct? Because this folder has this permission. Users with write access cannot delete or rename files they do not own. Okay? So even though the student user has, oops, what I'm doing here. Even though the student user has full permissions, he can write, he can only delete what he created. Why? If you see the T here, it has this folder has the sticky bit. See there? Sticky bit. Since this folder has the sticky bit applied, it means even though you have full permissions, you can only delete what you could have created. So this is very similar to a Windows permission that is called created owner. It's not the same thing, but similar. So if a folder allows full permissions to everybody, if a folder has full permissions to everybody, without a sticky bit, everybody can create and delete. It's complete chaos. But with the sticky bit applied, which is the case of this one, they can only delete what they have created, which is quite nice. How nice is that? It's very nice. Cool. So this wraps up special permissions. I'm going to leave them here for a couple of seconds. Okay. Not this. Shit, this. It's fine. Okay. So guys can take a note. And we can move on. So this chart here. It's all available on the internet and everybody, and it is not no secret at all. It's everywhere. Now let's wrap things up with the last part. So let's discard this. Let's discard this, and let's discard this. So let's let's discuss the last thing of today, which is the default permissions. Even though it's easy, it just requires a couple of things to be understood. Which is, for example, I got that wrong. Yeah, the home. The home. It's strange chat. It's saying that your chat message was 14 days ago, which was not. Weird. Yeah, the home. It's a good hint. It's a good hunch, but it's a var temp. Because the home, you can write only to your own thing. So student writes to student, Alice writes to Alice, etc. Right? So var temp, everybody can write there, and slash temp, everybody can write there. I mean, everyone can write to his or her own folder, right? So coolio. Yeah. So where was I? But I like that you tried, Osito. All right, I like that you tried. Cool. Default permissions. That was kind of in the stump here. Yeah. Cool. Yeah, let's create a new folder. MKDears, just for funsies, new folder. And let's, for example, create a new file. And a new directory. Oops. I did not. Cool. Cool. So when I create a directory, these are let's quote unquote. When I create a new directory, these are the default permissions. When I create a new file, these are the default permissions. Now, the thing I'm going to tell you next, be careful because it can be different or slightly different between Linux distributions. Okay, so this is kind of the Red Hat thing, but if you go to a different distribution, it can be slightly different. So are these we can call this the de facto default permissions. So when you create a folder, these are the permissions that are applied when a freshly created folder. When you create a file, this is the default permissions created to a freshly created file. Okay, cool. But these are kind of manipulated in a good way by the file system, because these are not the de facto default permissions. They are exposed by checking the umask thing. What is the umask, you say? I'll explain in a second. So let's first say that the umask does nothing. Let's kind of nullify the umask. And now we create new dir with umask 0000 and the new file 0. Now this is going to expose the exactly default permissions for this specific file system. And directories are created with full permissions. Files are created with full permissions except execution. So these are the de facto default permissions. These are the default permissions. But the umask here is at play. So what was the default umask? It was 0022. What does this mean? It means that, for example, let's see a file. So this is the new file without the umask. What did happen? So 22. What does the 2 permission mean? We know this. 4 is write. Sorry, 4 is read. 2 is write. 1 is execute. So we are talking about the write permission. And this is a little bit different. This is not exactly as I'm going to expose it, but it's the simplest way I have to explain at this point, and to make it as simple as possible, which means that I'm going to subtract the permission 2 from the de facto ones. So these are the de facto ones. So I'm going to subtract the 2 here, and I'm going to subtract the 2 here. So this is the de facto starting point. New files will have the write permission subtracted from the others, the write permission subtracted from the group. The rest stays as it is. Of course, if I do this, then new files will be read, read, read. Because I'm subtracting the write here, here, and here. This is very easy to understand, but you need to make sure that you know what are the starting permissions. These are the starting permissions for a new file. These are the starting permissions for a new directory. So with this, a new directory is going to be not full permissions, but read, execute, read, execute, read, execute. Read, execute, read, execute, read, execute. Why? Because we start here and we subtract the write here, the write here, and the write, the write here and the write here. So this is the de facto start. We subtract the 2 here, here, and here. Okay, so if I am root, let me see. For the root user, did I mistype it? The umask is the same as for a regular user. All right? Which means if I log out and if I open a terminal again, I can see the default umask being applied. All right? So even though I can change the umask here, umask, if I log out and I reopen my terminal, it's going back to the other one, because this is written down where doesn't really matter at this point. We will discuss this in the RH124, but this is the default umask is written to a file that is applied every time I log in. Oops, sorry. So even though I can't change the umask right now, it's not a permanent change. I can make it permanent, of course I can, but I will not. Going back, what was the name of the folder? New there? I need to be a little bit more specific with the folders. Nope. New folder? Yeah. Come on. Okay. So the umask subtracts from the original permissions that the de facto default permissions, so that's what I mean, that can only be exposed by nullifying the umask. If I nullify the umask with 0000, then I expose the real default permissions, which is typically for the udir full folders, for the new file, read write, and the umask is going to retract from there. So I will subtract the write from here and subtract the write from there. But first, I need to expose by nullifying the umask. Now, why do I see a fourth permission? We only have read, write, execute. 3 permissions, right? We only have 3. So why do I see a fourth one? I see a fourth one because that represents the special permissions. Set user ID, set group ID, and sticky bit. Set user ID, set group ID, and sticky bit. So this is going to subtract if there are any default permissions of that kind. That's also why sometimes you'll see chmod, let's say. Now going back to the regular permissions, let's say you want to give 444 to new file. Which is fine. But you also want to give the set user ID. That's given by the fourth permission here. So you can go to, for example, man chmod. And it's kind of given you here. It's here. So set user ID is 4, group ID is 2, sticky bit is 1. So if I want to give the set user ID, it's 4. So let's say I want to keep the same thing, but I just add a 4 here. So in theory, this new file will have read with the S. All right. That's why you see a fourth permission here sometimes, because the leftmost one, it's either set user ID, set group ID, or sticky bit. Ain't that nice? Almost 2 hours, well, if you include a coffee break, of good and interesting information. So at this point, are there any questions you may ask, or else we can wrap things for today? Telling you thank you very much. Like, subscribe, hype, and comment. Don't forget, this VOD is going to be available to everybody in YouTube, not on Twitch. Twitch, I don't store VODs. And for members, even whatever the tier, you'll have an edited down version without coffee breaks, introduction, jibber jabbers. Everything goes directly to the chapter itself. No problem with CTO. Next week, meet you in everything goes as to plan. 9 a.m. Wednesday, 9 a.m. GMT, chapter 12, which is going to be managing packages and RPMs. I'll see you there. Thanks, everyone. Like, subscribe, and hype.